Okay, the next one we're asked to differentiate the arctan of bx over a. So the first thing we have to do is, since y is that, means that bx over a is the same as tan y. Do you get? Moving tan y to the left, that's it. And making x the subject of formula, we see that x is now a over b tan y. So let's now differentiate x with respect to y. You have the x over the y is now, remember a and b are constant, so a over b, if you differentiate tan, is x squared. Do you remember? Okay, and we know we are given tan inverse of this, so we need to convert this to tan, because that's what we are given. So from our Pythagorean identity, if you remember, that 1 plus tan squared is x squared. So I can replace x squared with 1 plus tan squared in that. So I have a over b. This is now 1 plus tan squared y. And from this, you can see that it's a over b 1 plus tan. Tan is b x over a, so I have bx over a all squared. Remember, this is just the x over the y, not the y dx. So if I do the y dx, I now have b over a times 1 plus b. Okay, let's open up b squared x squared over a squared. That's it. So this is now b over a. The LCM here is a squared. So I have a squared plus b squared x squared. So which is equal to, okay, we now have that, this can cancel, so I have b over a squared plus b squared x squared over a, because 1a is gone. I know this is this divided by that, so which is now ab over a squared plus b squared x squared. So that's our derivative of arctan of bx over a. So if someone asks you to evaluate the derivative of arctan of maybe 5x over 2, so the answer, without wasting time, our a here is 2, our b is 5, so I have 2 times 5 over 2 squared plus 5 squared x squared, so which is 10 over 4 plus 25x squared. So that's our answer. So without wasting time, so once you know this formula, it helps us to solve that. So the next one is y equal to cosec of bx over a. So the same way, if I move cosec to the other side, is now cosec. So I have bx over a equal to cosec y. And if I make as the subject of formula, is now a over b cosec y. Okay. So we now let's differentiate x with respect to y, since I have x and I have y here. And I have, if you differentiate cosec, the answer is minus cot cosec. Do you remember? So that I can write it as minus a over b cot y cosec y. That's dy dx. Sorry, the x dy. So if I now do dy dx, I have b over minus a cot y cosec y. And if you remember our Pythagorean identity, that 1 plus cot squared is cosec squared. One plus cot squared is cosec squared. So we can use it here. Because what we are given in the equation, we are giving cosec. So we need to convert cot to cosec. So from, okay, maybe let me write but from, so that we can use but from, but 1 plus cot squared y is cosec squared y. So we know we are giving cosec, so it's settled. So we need to convert cot y to write cot y in terms of cosec. So if I make, implies that making this the subject of forms, I have cosec squared y minus y all in square root. So our dy dx now is now, okay, maybe let's write the minus here, minus b over a. Let's write cosec first. Just I said to write cosec first. Y cot is now square root cosec squared y minus 1. So they have told us that cosec is bx. Cosec is bx over a, so we substitute. So I have minus b, a cosec is bx over a times b squared, that's b, okay, bx over a all squared minus 1. So this is, as you can see, a, and I have b, so I have minus 1 over square root of, that's x. There's x here. To get a, b, so we left it x down here. Why this is b squared, x squared over a squared minus 1. So we'll still continue. So we've gotten that the y dx is minus 1 x square root of b squared a over a squared. So b squared x squared over a squared minus 1. So which is minus 1 over x. LCM is a squared. So square root of b squared x squared minus a squared. You get a squared in a squared is 1 times that, so minus. And square root of a squared is a. So I have as minus 1 over x square root b squared minus bx squared minus a squared over a, because square root of a squared is a. And you know this divides by this, so we can write this as minus a over x square root b squared x squared minus a squared. So that's the derivative. So if someone asks you to evaluate, that's dy dx. Evaluate d over dx of cosec minus 1 9x over 4. So our a is 4 and our b is 9. So we can see that we've gotten that dy dx of, that's the we've gotten that d of the x of cosec bx over a is equal to minus a over x that minus a over x square root b square x squared over minus a squared. Therefore, the dx of cosec, that's arc cosec of 9x over 4, is now equal to minus 4 over x square root 9 squared x squared minus 4 squared. So this is minus 4 over x square root of 81 x squared minus 16. So that's the answer.